Guys, we are back and we will be doing question 67 from the June 2007 regions, which involves springs and elastic energy. Well, elastic potential energy. For question 67, it says the toy is activated and all the compressed energy. Well, before I start, actually, we already did the question 66. This is a continuation of the problem. The information is already given to us. We will assume that you already watched question 66. But the toy is activated and all the compressed springs potential energy is converted to gravitational potential energy. Calculate the maximum vertical height to which the toy is propelled. So first of all, we can, of course, like last video, get started on what they are asking for. This is all the information for the last video, if you were wondering. But anyways, it is asking for the maximum vertical height. So I guess you can put height is equal to question mark. Next we can basically go off the givens. I'm not really going to rewrite the givens, since for all the givens we already have the only givens that I will actually rewrite is the potential energy, since that's the one that I think we're gonna use. These givens right here we can just refer back if we actually need to use them. So potential energy spring will be equal to 0.19 J. I'm just going to use 19 or 0.19 since it will be easier to use. Then mass, of course, I'll just rewrite it. Mass is 0.02 kg. And let's see, what else do they give us? Oh, and since they do actually, in the problem, they actually mention is converted to gravitational potential energy. One thing that we actually do know that we can try out is that we can write gravitational, or the force due to gravity, or G, is equal to 9.81. This is stated in the meters per second squared. This is stated in the reference sheet if you need help finding that. And from here on, we of course just have to find the formula that we have to use. One of the formulas that is in the reference sheet is, of course, the change in PE is equal to mgh, or change in h. We will just write it as mgh to make it simpler. So this formula, since it is asking for the height, the vertical height, all we have to do is isolate the height. So the first thing we can do to get started is to plug in all of the values. So we can put parentheses 9.8 19 joules is equal to 0.02 kg. Let's put that in parentheses, make it more organized, times 9.81, well, meters per second squared. Let's stretch that a little bit. There we go. And times height, which is what we are trying to find. Next, I think the next thing that I actually will do is that I will divide both sides by 0.02, and if I divide both sides, it will cancel out on the right side, and it will divide this. Let me just write it quickly here. 0.02, 0.02. If we write that, then it will be equal to 9.5. I will actually leave the units for later, that way I don't get confused, which is you can always leave the units, you just put it on the end. So you can put 9.5 joules per divided by kilograms per kilograms is equal to 9.81. Let's actually write that, joules divided by kg, I believe, yeah, is equal to 9.81 meters per second squared times height. And from here on, all that's really left is to just divide 9.81 to both sides to move the 9.81 to the other side. 9.81 meters per second squared, that will cancel it out on the right side. We actually put a line right there to show that it's canceled. And it will bring it to this side. Well, divide 9.5 by 9.81. Let me write that actually. before I forget. 9.81. 9.81, that's really far off, but the information is what matters. So after you do that, it will be 9.5 divided by 9.81. It is equal to, if you take out your trusty calculator, it is equal to 0.97 meters, actually, because well, when you substitute, well, when you cancel out all the, you know, all the units and all that, it will in the end equal to meters. Also, because it is asking for a distance, which is the height, you can always assume that it's meters. I mean, if it's asking for like vertical distance and you get a unit that's like newtons, you know, you of course did something wrong. So in the end, height, vertical height, or change in height is equal to 0.97 meters, and that's it. That is the problem.